In the limiting reagent mole-to-mole tutorial, you learned how to calculate the limiting reagent when given the moles of reagents to start with. However, usually for chemical reactions, we weigh out our starting materials. What happens if instead of being told the number of moles of each reagent to start with, we are told the number of grams of each reagent and are asked to determine the limiting reagent? Let's go back to our s'mores analogy. To make a s'more, one must have 2 graham crackers, 1 chocolate bar, and 1 marshmallow. We are told that we have 200 grams of each ingredient. How many s'mores can we make? To solve a limiting reagent problem, you must have a balanced equation to relate the amounts of reagents and products. The balanced s'mores equation is 2 graham crackers plus 1 chocolate bar plus 1 marshmallow makes 1 s'more. We also need something else. If you have 200 grams of chocolate bars and 200 grams of marshmallows, would you expect to have the same number of chocolate bars and marshmallows? No, you would not. 1 chocolate bar weighs more than 1 marshmallow. We need to know the masses of the reagents too. Just like chocolate bars and marshmallows, chemical compounds have different masses. We need to consider this when doing calculations. Consider the following reaction between ammonia and oxygen gas. Just like the s'mores equation, this chemical equation must be balanced. If 4 grams of ammonia mixed with 10 grams of oxygen, determine the following. How many grams of nitrogen monoxide will form? What is the limiting reagent? Just like the marshmallows and chocolate bars, ammonia and oxygen have different masses. We need to figure out the relative number of ammonia and oxygen molecules we have. To do this, we will need to use the molar masses of the reagents. To determine the limiting reagent, calculate how many moles of NO that can form with each reagent. We will first calculate the number of moles of NO formed from 4 grams of ammonia. We start with the measured quantity of 4 grams of ammonia. To convert mass to moles, use the molar mass. Put grams on bottom to cross-cancel the units. To convert moles of ammonia to moles of NO, use the molar ratio given to us from the coefficients in the balanced equation. With cross-canceling, we are left with moles of NO, which is the unit of our desired answer. Plugging this into our calculator, we get 0.24 moles of NO. This tells us that 0.24 moles of NO will be made from 4 grams of ammonia. Pause the video to calculate the moles of NO formed from 10 grams of oxygen. From 10 grams of oxygen, 0.25 moles of NO can be made. Because ammonia can only form 0.24 moles NO, while oxygen can form 0.25 moles of NO, ammonia is the limiting reagent. It limits us to only forming 0.24 moles of NO. Therefore, 0.24 moles of NO will be formed. The original question asked for the mass of nitrogen monoxide that will form. We will use the molar mass of NO to calculate how many grams of NO are in 0.24 moles. The molar mass of NO is 30 grams per 1 mole. Start with 0.24 moles of NO. Using the molar mass to convert moles to grams, we put the moles on bottom to cross-cancel the units. The units we are left with, grams of NO, are the units of our desired answer. Plugging this into our calculator, we get 7.2 grams of NO. Oxygen was the excess reagent. How many grams of oxygen are left over after the reaction has completed? The first step in this calculation requires determining the number of grams of oxygen that reacted with 4 grams of ammonia. We will subtract this number from the 10 grams of oxygen we started off with to get the number of grams of oxygen left over. Pause the tutorial to solve for the mass of the remaining oxygen. We start with the measured quantity of 4 grams of ammonia. To convert grams to moles, we use the molar mass of ammonia. Put 17 grams on bottom to cross-cancel the units. To convert moles ammonia to moles of oxygen, use the molar ratio given to us from the coefficients in the balanced chemical equation. Put 4 moles of ammonia on bottom and 5 moles of oxygen on top to cross-cancel the units. We have moles of oxygen, but we want to find grams. We use the molar mass of oxygen for this conversion. Put 1 mole of oxygen on bottom and 32 grams on top to cross-cancel the units. With cross-canceling, we end up with grams of oxygen, which is the unit of our desired answer. Plugging this into our calculator, we get 9.4 grams of oxygen. 9.4 grams of oxygen reacted with 4 grams of ammonia to form 7.2 grams of NO. Because we started out with 10 grams of oxygen, we subtract 9.4 grams of the oxygen used to get 0.6 grams of oxygen left over. Let's organize our thinking on the general stoichiometry involved with limiting reagents. We start with grams of A, with the desire to see how many grams of B can be formed. A general pathway must be taken to convert grams of A to grams of B. You cannot convert grams of A to grams of B directly. When you hypothetically weigh out the mass of A, it is in a pile. You do not know how many particles of A were weighed. If you convert this mass to moles, you will know the amount of A that you have. This conversion is done with molar mass. The connection between moles of A and moles of B comes from the balanced chemical equation. This allows us to calculate moles of B. If we want to know how much the moles of B weighs, we must use the molar mass of B. This pathway must be taken as you cannot go from grams directly to grams.